Hey everybody, thanks so much for being here. Thanks to Big Data London for having me, and thanks to you all for delaying lunch by a few minutes to come and talk about R. I think it's worth it. I hope you'll agree at the end of the talk. My name is Alex. I'm a solutions engineer at RStudio. If you want to tweet at me, my Twitter handle is there. The hashtag RStats is sort of the hashtag for generically all things R. It's also just a delightful place on the internet, all too rare in 2019. So check it out if you haven't checked out the hashtag RStats on Twitter. The slides and the code are going to be available here on my GitHub. So please feel free to go there and get those. So let's get started. So if you've heard anything about R for big data, it's probably that R is not for big data. So that's bad. What I'm here to tell you is that what you've probably heard is that R it's just slow. It's single threaded, so you can't do parallel processing. That's not great for big data, and that you can only use in-memory data. And all of these things are absolutely true. But also, they really don't matter if you adopt some sort of smart paradigms for using R with big data. So we are A-okay. So let's talk about it. We're going to spend a little time on the just slow and the single threaded, and then we're going to spend a lot longer on the in-memory issue and how to sort of tackle those. So to the single threaded point, you have to do parallel processing more or less manually in R, but there are a lot of really great packages that make this really easy. My favorite is the Do Future package in R. Super highly recommend it if you're looking to do parallel processing in R. Also, the RStudio Server Pro Launcher feature is a new feature we released earlier this year that can make it really easy to launch asynchronous jobs. If you have, say, long-running simulations, long-running models, that can be a great way to run that. To the just slow point, it's usually fast enough. It's totally right. R is not as fast as a lot of other languages that are compiled, especially C++ or things like that. But usually it's fast enough. And there are a bunch of good profiling packages. I recommend ProfViz as a way to sort of check your code, figure out where the slow parts are, and then speed up the parts that you need to. That's a really great way to do it. If it's still too slow, if R is just really too slow for you, that's okay. There's a package called RCPP that lets you write super blazingly fast C++ code and call that from inside R. So really the speed limitations are just all about, if you want to go all the way down to using C++, totally an option. Go ahead and do that. That's great, and RCPP makes it easy. And just to that point, this is a woman named Heather Nolis who works at T-Mobile. She's written a number of APIs, and those are hit over 4 million times a month. This was a few months ago, and when she gave this talk, she was saying that they've been growing ever since then. So lots of growth there in the use of R at speed. WIT has 20,000 requests per second handled by Plumber on a single node. Plumber is an API building package for R. And lastly, this was at our conference last year at the RStudio Conf. Sean Lopp did a live demo of 10,000 concurrent users accessing a Shiny app. So it definitely can scale. You have to be a little bit smart about it, but totally possible. So let's move on though to this in-memory issue, because this really can be a big problem, and I want to share some thinking around how you can sort of get around that. So, if you're doing big data tasks or even moderately sized data tasks, you've got your big database over here. You've probably got a big development machine too, but in the middle you have this tiny little pipe, right? And this is really a problem, particularly if you're in the early stages of a data project, when you're doing that iterative development, right? You're pulling data constantly, you're remodeling, you're doing this again, right? That can be a real pain if that transmission time is not super short. So how do we attack this problem? So I'm going to share 3 big data strategies for R, 3 ways to think about using big data with R. So let's get started. Strategy 1 is called sample and model. And so with this strategy, you'll take your sort of big old data set, and inside your database, right, you'll downsample into a smaller sample. And the other thing I should say just real quick is if you have a Spark cluster, all of this works exactly the same using the sparklyr package. So this also works in a database. It works in Spark. There are other ways you can do it as well, but this is totally transferable to a lot of sort of different ways of using big data, not just databases. So within the database, you're going to downsample to a smaller sample, randomly usually, and then you'll bring that sample into R and do your modeling in R just on the sample. So the plus side of this is you can use your favorite R modeling packages. I particularly recommend Caret, Parsnip, and RSample as some really great ways to do that. Another great thing is that it's really great for iterating and prototyping, right? You pull in a small model, you iterate, you prototype, you figure out what your model is going to be, and then you can push that back and run that on your whole big data set after you figured out, okay, these are the important features, that kind of thing. And depending on the size of your data, you may even be able to do all of the modeling just on your small sample. If you have really big data, you might not need all of it to create a really rich model at some point. A downside is that you have to be careful about your sampling and your scaling, right? So you have to be a little smart about how you downsample. Want to make sure it's a valid subsample. You may need to do things like stratify, or if you need to, oversample one class to get class parity, you can do that. The other thing is that if you're scaling back to your whole database, you got to be careful about the method you use, right? There are some methods that'll work fine on a small data set and then will just totally break on a big one. So you have to be careful about that. And the last downside is that this is not great for like BI kind of tasks, right? Anything where you need a total, a count, this is not great because you're not going to get that total. You're going to get a sample. If you're estimating some sort of parameter, great. If you need a count or a total, not great. So I'm going to do a little demo of the sample and model strategy. All the demos I'm going to do today are based on data of London planning permissions from 2006 to current. So that's data on basically buildings that are allowed to be built. And we're going to look a lot actually at like the time they took to actually get built. One thing I want to be really, really upfront about is that this is a bad model. I'm going to be doing a bunch of cheating because my point here was to demonstrate the database stuff, not like how to build a good model. So you can take my advice on database usage, but don't take my advice on modeling, or else it's going to be bad. So don't do that. So let's go here. So we'll go to the RStudio IDE. For any of you who've used the RStudio IDE before, this is just the desktop IDE. It's free and open source. You can download it in the middle of my talk, although I'd appreciate it if you wait until after, but whatever. So this is the IDE. I'm going to load up some libraries, and this is my database connection string. There are a bunch of different ways to connect to databases in R. This is probably the most verbose, but you'll notice that even here I'm hiding my password from you all because I don't trust you. So that's okay. Once I connect to the database, what you'll see is I have my connections pane down here, and actually, I'm sorry, this is probably really small for you all, so I'm going to make this like silly big. There's going to be like one word per line, but that's okay. And so what you all can see is that this is actually, I can explore my database a little bit from inside the IDE. So you can see some of the fields I have here. I have, these are about the times it took to do the work, right? Down here I have like the start month. I have some details about the buildings themselves, and then some stuff, some sort of metadata, right? The postcode, the permission type, who the planning authority is, that sort of thing. And one nice thing here about the database interface is I can actually click this view button and I can actually take a look at my data. So this is a live connection to the database, and I'm looking at here the top 1,000 records from my data. And this can be a really nice way just to get a feeling for like what's going on here. Like, for example, you might be able to tell that I'm American, so I know nothing about British postal codes. I had no idea they looked like this. I look at my data, I learned that, so that's great. So going back to my sample and model strategy. So the first thing I'm going to do is I'm going to pull in some data from SQL. And one other thing I want to share with you real quick is I'm going to show a couple of different strategies for pulling data into SQL into R from SQL. So one method is, this is an R Markdown document. It's a renderable document, which can be really handy. And here what I'm doing is I'm including a chunk, right? This is a chunk. Most of chunks are in R because it's an R Markdown document, but you can also include chunks in other languages, including Python and SQL. This one is a SQL content chunk. And so I have my connection specified here. I'm specifying where I want this to be output. And then this is just sort of vanilla SQL, right? I'm just selecting some columns, ordering it randomly, and taking 500 rows. So I'm going to just run that. Did that run? There. Ran. I've got 500 rows now. So let's take a look at how long it takes for properties to get finished. So this is the time from the permission to the time that the property is finished. And I've got this sort of nice density plot here. I put in that line at 5 years. It turns out about 13% of properties take 5 years or longer to complete. That sounds bad to me. I'm not like a builder, but like that sounds not good. So maybe we should if I were working for a building company, maybe I care about, is my building going to end up in that tail there, and can I avoid that fate? So we'll create a variable here that is the greater than 5 variable. This is a place where I'm doing something that's bad. I'm cheating. I'm just assuming any NA value is greater than 5 years, which is like a bad assumption. So don't do this, but again, that's not the point here. Then what I'm going to do is I'm going to use a bunch of R code to do my sampling, my modeling, and that kind of stuff. And so I'm not going to spend a lot of time going through the modeling code here. If you're interested, Max Kuhn is actually teaching a workshop here in London on Monday. There are still spots left, I believe. But his is the team that writes all these packages. But what I'm going to do, right, is I'm going to do tenfold cross-validation. I'm going to model this, whether it takes more than 5 years to build these buildings. I've got a function here that runs my actual model. And now I'm going to here run my tenfold model there. And you can see that was really, really fast, right? This is only 500 rows. Really doesn't take long to build a model on that few rows. And I'm going to get sort of some of my goodness of fit metrics. So it's not terrible, right? My baseline rate of taking more than 5 years was about 9%. My prediction accuracy is about 90. So maybe that's not terrible. I don't know. We need to do more assessment. Again, good model, not the point here. So that's the sample and model technique, right? I took a big data set, downsampled it, did a bunch of modeling that was very, very quick because I did it only on a sample. Again, works really, really well when you're iterating and prototyping, and I'm trying to figure out what variables go in, what comes out, that kind of thing. So that can be a really, really nice solution there. So the next strategy I'm going to share is called chunk and pull. So with this one, I'm going to start off with my big data set, and I'm going to downsample it, but this time I'm going to do it according to some sort of logical unit. Maybe that's time, maybe it's like each month I want to look at separately, maybe it's a week, maybe it's a year, maybe it's a geographic unit, maybe I care about this county separate from that county or this town separate from that town, or maybe it's a logical unit, maybe it's a business unit, right? Maybe it's one part of the business compared to the other, one product compared to the other, or something like that. And so what I'm going to do is I'm going to take just the data for that chunk. I'm going to select it in the database. I'm going to pull that into my compute machine in R and do my analysis on that in R, completely separately from the other chunks. And then I'm going to do that across all of my chunks, right? This chunk, that chunk, all of the chunks. Eventually, I'm going to do that for all of the data, or at least all the data I need. A plus side is this works really well when discrete chunks exist, right? When you have those logical chunks, this can be a really good strategy to get that data in a nice way. This is also really good at facilitating parallelization, right? If any of you know a little about parallelization, right? It's easy to see that this is going to be embarrassingly parallel, and so easy to sort of run it in parallel as opposed to in sequence if you wanted to do that. The one downside is you can't have any interactions between the chunks. So like if your data from this month needs to interact with your data from last month and you're trying to use months as your chunks, like that's just not going to work here, right? Not a good strategy for this. And the other downside is that you eventually have to pull in all your data, right? Assuming your data is sort of a partition of your complete data set, eventually you have to pull it all in. So this may or may not actually save you time, depending on how it works. But it could certainly save you time maybe if your model scales like faster than linearly in time. Let's go to a demo. Also, here's a video of a cute puppy who stinks at catching food. No particular reason, I just thought it was really cute. That's pretty great, right? Man, dog cannot catch food. So sad. That must be so sad. It's coming at my face. Fail. So, back to the topic at hand. So we've got our database connection. We're going to establish it exactly the same way, so I'm not going to bother rerunning that code. Here you can see this is a second way to pull out a SQL query into R. And so here I'm using this is from the DBI package, which is a database interface, is what DBI is short for. And so I have this db get query function. I give it a connection, and then this is, again, just sort of vanilla SQL inside quotation marks. This can be nice because I can assign this back to a variable. And one other quick R trick that some of you may or may not know is if I take any R statement and enclose it in parentheses, it'll print immediately after I run it. So this is really, really handy if I want to like run something and just print it. I don't have to like do any extra work. I just put it in parentheses and it prints immediately after it runs. So that can be really handy just to know. So here what I'm looking at is like the different planning authorities that exist here in London. So this is the planning authorities and the count of how many permissions I have in my data set for them. And so now what I'm going to do is I'm going to plot the total time it took against proposed floor space for each of these planning authorities, right? So this is very clearly a chunk and pull kind of task, right? I'm doing totally separate plots for each of these authorities. So all I need is the data for each one separately, right? I can pull down that chunk, operate on it, be done with it, okay? Again, this is just some ggplot code that I've wrapped into a function to be able to, this is the function that's going to actually do my plotting. And then I've got a function down here that I'm going to run. And this is actually going to pull in the data set, do my plotting, and then save it out here. Most of this is just manipulating the planning authority to make sure I have it without like spaces or that kind of thing. So if, in terms of the actual chunk and pull, like here lines 88 to 94, like this is the actual chunking and pulling that's happening. So I'm taking these variables from the table, and you can see I'm using the glue package here, which has this really nice syntax for inserting a variable into a text string, right? I just enclose it in those brackets, and then I get the value of the variable printed into the text string, which is just a really nice way to interact with text strings there. So I'm going to load up that function. Now I'm going to create these plots, and if I go over here to my file browser, you can see that they are getting created as we speak. It really doesn't take very long, right? Because I'm pulling down like, I don't know, a couple thousand rows at a time, runs very quick. And here is that plot in log. So it's not super interesting, but again, point here wasn't to show like super cool data about planning permissions. It was to demonstrate that databases are really cool and can work well in R. So again, what was really nice is that I was able, though, to loop across all of my planning authorities here pretty quick, right? Because that data comes down really fast when it's just a small data set, which is really nice. All right, so we got one more. Oh, and back to that dog. What a great day. So the next strategy I'm going to talk about is calling pushing compute to the data. And this is sort of generally, the other two are sort of a little bit of a special case of this. So what I'm going to do here is I'm going to start, though, with my development machine. I'm going to write some code that does something I care about. I'm going to push that back to the database. It's going to run somehow and somehow compress the data, right? In the other two cases, it was just sort of like selecting some of the data. In some cases, I can actually summarize the data in some way, right? Run an operation in the database that does some summarization, compresses my data, and then I only have to bring that compressed set back over, which is really nice, and then do whatever I want with it in R. So, good thing here is I get to take advantage of database strengths, right? Databases are generally pretty good at like aggregating and summarizing and that kind of thing, so that I want to do that there, right? I don't have to bring all that across the pipe. I get to take advantage of the whole data set, right? Both of the other strategies, I couldn't take advantage of the whole data set, at least not at the same time. This is a really nice strategy to let me take advantage of the whole data set, which is really nice. But I end up moving less data, right? Because I've compressed it, I've gotten it sort of smaller ahead of time. That's really nice. A disadvantage is that sometimes you might want to do like window operations or other kinds of functions that your database engine doesn't allow for whatever reason. This is a totally real problem that sometimes limits you being able to do this. And the other one that I've heard before is like maybe your database is the problem. Sometimes you have a really nice compute machine that has plenty of horsepower. It's like good to go, and your database is just really slow. And so you want to avoid doing stuff in the database as much as possible. In that case, maybe not the best choice for you. Oh wait, no, I shouldn't quit yet. We've got another cute dog video to look at. Oh my gosh, amazing. So let's go. This is pushing compute to the data. So this time I'm going to use a different way of interacting with my database. So the first two I used were, I used an R Markdown chunk to send a SQL query off to the database and get it back. Second time I used the DBI package, again, to sort of write a vanilla SQL query, fill in any variables I needed with the glue package, send that query off. This time I'm going to use the dplyr package to send commands off to the database. Just a quick show of hands. Who here is familiar with dplyr? Okay, cool, about half-ish. For those of you who don't know, dplyr is a very popular R package for sort of manipulating and managing data. And one of the cool things about it is that it can use a local data frame in R's memory as a way to store data, but it can also interact with different kinds of remote data tables. And one of those is that you can actually have a database that serves as the actual data backend for dplyr code. So this is pretty cool. So here what I'm doing is I'm connecting to my database, and so this prints, if any of you have used R before, like this prints just like a normal data frame, but this is actually the database, right, talking to dplyr and giving it that code that runs it. What it does on the back end, just in case you're curious, is it actually does a translation from the dplyr code to like SQL code, and then it shoots that off to the database and runs it. You can look at it if you want, and it's super weird looking SQL because it's by a machine, but it's kind of cool. So now what I'm going to do is, this is like an example of pushing compute off to the data, right? So what I want, let's say, is I want like the mean, median, and total time by permission type of the time it's going to take to get these permissions done. I could just pull all this data into R and do it there, but I'd rather, right, with the push compute to the data strategy, I'd rather push that compute off to the data, run the summary on the database, and then pull back only what I need. So this is vanilla dplyr code. Any of you who's used dplyr, this should look very familiar, right? I'm grouping by permission type, summarizing, and then collecting here at the bottom. Collect is the one function here that is specific to using dplyr with a database. Collect means get this from the database, right? Until then, it doesn't actually get it. It just sort of computes it and holds it, right? When you run collect, that means bring it back for me, right? And so that's the important step here that makes this different from, let's say this were just a local data frame, I would leave out this line. It would just be the lines above, okay? So now I'm going to pull that in, and you can see what I pulled in was 7 rows, right? That made my life way easier than having to pull in, however big this data set is, right? So I pulled in these 7 rows and the few columns. I have my mean, my median, my total, and this is really convenient, right? It went really fast. What I want to show real quick is the bad way, right? So the bad way would be I take my data frame, I'm going to collect it all in first, right? I'm going to transfer it all into R, then group and summarize it after I've pulled it into R. So this is the bad way, and so the good way took about 0.13 seconds, which is pretty fast. The bad way was also pretty fast, but it took more than twice as long, right? So at this scale, that time didn't really matter, right? It was, a 0.15 seconds versus a third of a second. But you can see, right, as you start scaling this up to actually really big data sets, this can really matter if you can push that compute off as opposed to bringing everything in locally. So that's way one you can push compute off the data, right? Use dplyr, use other things to bring in as little data as possible after you've run your summaries on it and that sort of thing. The second way to push compute to the server is to use packages to do your work for you. There are a variety of R packages that let you push work off into databases that are pretty cool. So the first one is called dbplot. Just a quick show of hands, who here has used ggplot in R? Okay, awesome, yeah. ggplot is great. It's one of the really popular plotting packages in R. So dbplot is very similar to ggplot. It actually creates a ggplot object. But what it allows you to do is put in a database and specify some operations you want to do, and then it will plot a line plot. And then this is all just vanilla ggplot code that I run locally. But I get this really nice line plot back. And again, because I did all that computation in the database, my life is way easier as opposed to having to pull the data back first before I did all that computation. There's another package called ModelDB that can do something kind of similar. So here I'm going to run a linear regression in the database. I think actually this is really cool that you can run a linear regression inside the database. It is somewhat limited in terms of the types of models it supports. Currently, I think it's just k-means and linear regression, but better than nothing if you have a really big data set and that's all you can do. So you just sort of select the variables you want. You have to manually sort of dummy out variables that are categorical, like start month is here, and then I'm going to run a linear regression here, and it shouldn't take very long, even in my entire data set. There we go. So here I've got my coefficients, which is cool. One of the limitations here you'll notice is I don't get goodness of fit metrics. It doesn't compute standard errors or anything like that if that's a thing that you care about. But it's not so hard. It took me a little while because I'm really lazy and didn't want to write out 12 different month statements, so I wanted to do that automated. But it's not hard to create, here I'm going to compute the RMSE for this. So let's see if I think this will run better this way. Well, I have an error in my code somewhere. Unexpected error, update. Anybody spot it? Looks good to me. There we go. Okay, it ran that time. Weird. And so what you can see is now, just a quick thing what I did there, right? I created a prediction here that was just based on the non-sort of month-by-month variables, then added in sequentially. That's this line. Added in, oh no, sorry, that's here. Added in each of the month variables as appropriate. And then I'm going to compute the RMSE at the end based on the prediction. So this RMSE is 4,256. I think that's probably bad, but I don't really know. So that's fine. But again, the point is here that I did all that computation in the database, did my linear regression in the database, and then did my RMSE in the database, which is very cool, not having to bring any of that back to R. Here we are. We'll hang here for just a second. This is the last cute puppy in the presentation, so maybe you want to soak it in while you've got it. So again, three big data strategies for R. Sample and model, chunk and pull, and pushing the compute to the data, right? All three of these can work great depending on your use case. None of these are perfect though, right? For all of them, there are downsides. There are things that just don't don't work that well. But the main thing is that you don't have to choose just one. You can use all of these in combination. Sometimes you can use 2 or 3 at the same time on the same project. So what you might be asking though is like, why would you do that, right? Why would you do this in R when you could do it in Spark? You could do it in Python. You could do it in vanilla SQL. Why would you do this in R? And I think that's a totally valid question. I do have an answer though. That's why I posed it. So, a lot of times when we think about what are we doing with big data, what we think about is this sort of modeling step, right? We're building a model or something like that, or we're doing, statistics of various sorts. But there's so much more you can do, right? There's this whole discovery process of visualizing and transforming your data that you want to do as well. And before you even got there, right, you wanted to import and tidy your data. And after that, you want to automate something or communicate something with your data. And the cool thing about R is that R can do all of these different steps, right? R can be involved at every stage in the process. And so using R as an interface where it doesn't work well, right? You interface with your database, use your database to do the work, and then do the things in R that work really well, right? Plotting in R is a great experience. So do that part in R, interface with the database for the part that R isn't great at. So that's a really nice thing about R. Tina Fey thinks it's awesome, so you should too. And so one question we always get is like, what if I want to deploy my model, right? What if I want to put this out available for somebody? There are some open source free options. You can sort of build your own, right? You could totally create a website or a server that runs R. It makes this all work. There's Shiny open source. You could totally make this work. There's also Shiny Server that you could run this on. We also have some enterprise products at RStudio. Our flagship product for this purpose is RStudio Connect, which is really useful for this kind of purpose. And there are free evals of that. If you're interested, please come see us at the RStudio booth. We're 239, I think. But if you're interested, happy to talk to you about deployment in general. One quick thing I want to show is, because people are always curious about this, is this is an app that I'm going to run. This is a Shiny app, if any of you have seen Shiny before. It's a web framework in R for creating apps just using R code. So this is just R code that I created, and I'm plotting here the different variables against each other. I can change which variables I'm plotting, or I could change, for example, if I want to look at a different planning authority, I can do that all in this app. And what I just want to demonstrate here, aside from all the crazy errors I'm getting, is that there are a couple different ways I'm pushing the summarization to the data, right? Here I have a database connection. I'm pushing this off to the database. And here I'm using the dbplot function, dbplot raster, which makes this all work much smoothly, right? That would have been nowhere near that fast if I tried to pull in the data every time or load it up ahead of time. So this is a really nice way to integrate Shiny with some of these big data procedures, since I know some people love Shiny. I love Shiny. Excuse me. Again, if you want to come talk to us at the booth, that's great. So here is the summary of what I talked about. So these are the bunch of things that I talked about here. If you're interested in this stuff and you think it's cool, whether you want to open source or you need a professional or enterprise product, there are a bunch of great learning resources for you. So there's the website db.rstudio.com is all of our recommendations around how best to use databases with your own work. We have a lot of recommendations there about how to scale with them, how to secure them, how to make sure your credentials are safe, all that kind of stuff. And if you use Spark, we have a bunch of great resources on Spark. I can say this because I have nothing to do with any of them except that I've read them and they're great. So spark.rstudio.com is a site about the Sparkly R package, which is just a really wonderful way to use Spark and R together. And just recently, a couple of my colleagues released a book called The R in Spark. I cannot recommend it highly enough if you're interested in Spark. It's just a really good book, and it's freely available at the R in Spark. You can also pay for a print copy if you want it, but it's freely available online if that's what you want. Thanks so much for your time. I really appreciate it. And again, come see us at the RStudio booth if you thought any of this was cool. Thanks so much, everybody.